Substances can be classified according to their properties. In this topic, we will look at how substances can be classified and how their mixtures can be separated. Some of the methods used to separate mixtures include decantation, filtration, and evaporation. Let us find out how these methods are used in separating different mixtures. Some of the methods used to separate mixtures include decantation, filtration, and evaporation. Let us find out how these methods are used in separating different mixtures.
Decantation is a method used to separate an insoluble solid from a liquid. Sand and water is mixed and allowed to settle. The water is separated from the sand by allowing it to flow into a clean beaker. The solid is left at the bottom of the beaker.
This method is based on density. Sand being denser than water settles at the bottom, and water being less dense remains at the top. Decantation is therefore the process of separating an insoluble solid from a liquid-solid mixture.
Sand and water can also be separated by filtration. A filter paper is folded first into a semicircle, then into a quarter. The solid remains on the filter paper while the water passes through the filter paper.
Miscible liquid, liquid mixtures and liquid-solid mixtures can be separated using simple and fractional distillation. The process of distillation involves both evaporation and condensation. In the distillation flask, evaporation takes place. The vapor rises through the delivery tube and into the Liebig condenser filled with cold water, which cools the vapor, making it to condense to liquid. Simple distillation can also be used to separate two miscible liquids with wider range in boiling points.
Ethanol and water are miscible solutions and can be separated by fractional distillation. The solution is placed in a distilling flask, broken porcelain is added, and the Liebig condenser is connected. The more volatile substance, which is ethanol, with a lower boiling point of 78 degrees Celsius, condenses first. The water with a higher boiling point is left in the distilling flask.
Ethanol, whose boiling point is 78 degrees centigrade, boils first. Water, whose boiling point is 100 degrees centigrade, boils too. The fractionating column is packed with glass beads to increase the surface area for condensation. The vapor from the mixture rises up the fractionating column. At about 78 degrees centigrade, water vapor condenses and drops back to the flask, while ethanol vapor rises and is condensed in the Liebig condenser. When the thermometer reading rises above 78 degrees centigrade, most of the ethanol will have separated. We distinguish the two products by the smell and burning. That is, ethanol is flammable and water does not burn.
Crude oil is a mixture of hydrocarbons of petrol, diesel, lubricating oil, kerosene, and others. They are separated by fractional distillation. Oil and water are immiscible liquids. When allowed to settle, a mixture separates into two layers. The less denser liquid settles on top of the more dense liquid. Immiscible liquids are separated by means of a separating funnel. Solid iodine, when heated, forms purple vapor, which condenses as a sublimate. Sublimation is the change of state from solid to gas or gas to solid without passing through the liquid state. When ammonium chloride is put in a boiling tube and heated, it forms white fumes. The white fumes condense on the upper part of the boiling tube as a white solid. The solid is called a sublimate.
A mixture of solid common salt and iodine is placed in a boiling tube. The boiling tube is heated gently. Solid iodine forms a purple vapor which condenses on the funnel as a sublimate of iodine, leaving salt on the evaporating dish. The process is used in the purification of iodine. During the experiment, glass funnel was used instead of plastic funnel because the plastic cannot withstand high temperature.
When groundnut seeds are crushed in a mortar and propanol added, the resulting solution left in the sun, the propanol evaporates, leaving oil in the evaporating dish. The groundnuts contain oil. The oil is tested by applying some on the paper. It leaves a translucent patch on the paper. This method is known as a solvent extraction. The groundnuts contain oil. The oil is tested by applying some on the paper. It leaves a translucent patch on the paper. This method is known as a solvent extraction. When green leaves are crushed using a pestle and mortar and about 4 centimeters cubed of ethanol added, a green solution forms. The solution is decanted and 1 drop of solution put at the center of filter paper and allowed to dry. The green coloring matter in plants is a mixture of the two substances. The green color is due to the chlorophyll, while the orange-yellow color is due to the xanthophyll. The filter paper which contains the separated colored substances is called a paper chromatogram. A rectangular filter paper can be used in place of a circular filter paper. A drop of the green coloring matter is placed at the center of the filter paper. The filter paper is then dipped into the propanol and paper is removed when the solvent has moved 3/4 of the paper.
Each colored substance has a different solubility in the solvent and sticks on the filter paper to a different extent. Substances which are more soluble and less sticky are carried farthest. Less soluble and more sticky substances are left behind.
Chromatography is used to analyze substances and find out what they are composed of. Examples are blood, urine, and tea leaves. When a solution of copper 2 sulfate solution is put into a beaker and heated strongly, a saturated solution is formed. A gas rod is used to confirm that the solution forms crystals. If the saturated solution is put into a watch glass and left to cool undisturbed, crystals form after several hours. The crystals formed can be washed with cold distilled water and dried in either direct sunlight or between two dry filter papers. To obtain larger crystals, the solution is heated in a water bath, which allows for slow evaporation. Common salt can be obtained from salty lakes such as Lake Magadi by the process of evaporation and crystallization. One method used to determine if a substance is pure is by measuring its melting and boiling point. When pure naphthalene is heated, it melts at about 80 degrees Celsius. When camphor, which is an impurity, is added, it melts at a lower temperature. Impurities therefore lower the melting point of a substance. A heating curve can be used to determine if a substance is pure or impure. When pure water is boiled, it boils at 100 degrees Celsius. However, when salt is added to the water boils above 100 degrees Celsius. This shows that impurities raise the boiling point.
States of matter. In this topic, we will discuss the three states of matter and how they are affected by changes in temperature.
Matter exists in three states. When solid ice is placed in a boiling tube and heated, the ice melts into a liquid. When heated further, the liquid boils and forms vapor. Solid ice, when heated, melts. The temperatures at which the ice melts and the liquid boils can be recorded.
The results obtained can be used to plot a graph of temperature in degrees Celsius against time in minutes. At point AB, the solid ice is gaining heat. At point BC, the ice is melting. The heat energy supplied changes the solid ice into a liquid. At the point CD, the water formed absorbs heat and the temperature increases. At the point DE, the water changes into a vapor. The heat energy supplied is used to overcome the force of attraction between the water particles. During change of state, the temperature of a substance remains constant, but the substance continues to absorb heat energy. The temperature remains constant because the heat energy is used to overcome the force of attraction between the particles in a substance. At point AB, the solid ice is gaining heat. At point BC, the ice is melting. The heat energy supplied changes the solid ice into a liquid. At the point CD, the water formed absorbs heat and the temperature increases. At the point DE, the water changes into a vapor. The heat energy supplied is used to overcome the force of attraction between the water particles. During change of state, the temperature of a substance remains constant, but the substance continues to absorb heat energy. The temperature remains constant because the heat energy is used to overcome the force of attraction between the particles in a substance.
The three states of matter are solid, liquid, and gases. In each of these three states, the particles are arranged differently. In the solid state, the particles are closely held together. In the liquid state, the particles are farther apart and move much faster than in solids. In the gaseous state, the particles are very far apart and vibrate faster than in liquid states.
The temperature at which this occurs is called the boiling point. The changes that occur in the particles can be shown as follows.
The heating curve can be used to interpret these changes. The change from solid to liquid is known as melting. The change from liquid to gas is called evaporation.
Temperature rises steadily as ice absorbs heat energy. Temperature remains constant as all the ice melts. The temperature rises steadily as heat energy is absorbed until the liquid boils. The temperature remains constant as boiling continues. From the graph, constant temperature represents change of state.
The process of changing a solid into liquid by heating is called melting.
The heating curve can be used to interpret these changes. The change from solid to liquid is known as melting. The change from liquid to gas is called evaporation.
The process of changing a solid into liquid by heating is called melting. The process of changing a liquid into gas by heating is called evaporation. The process of changing a gas into liquid by cooling is called condensation. The process of changing a liquid into solid by cooling is called freezing. The process of changing a solid into gas without going through the liquid state is called sublimation.
When different substances are heated, they undergo changes differently.
Temporary changes. Different substances are affected by heat differently. In this subtopic, we will discuss how some of these zinc oxide, candle wax, and iodine are affected by heating and cooling them.
When a small amount of zinc oxide is heated in a test tube until no further change and allowed to cool, white zinc oxide changes to yellow, and on cooling it changes to white. When solid wax is heated, the wax melts. On cooling, the wax solidifies again. When iodine is heated, the iodine sublimes. On cooling, the iodine vapor solidifies.
Note that when iodine is heated, it changes directly from a solid to vapor. This process is called sublimation. Sublimation is the process of changing a solid directly to vapor without going through the liquid state. When solid iodine is heated, it changes to purple vapor, which solidifies on the cooler parts of the boiling tube. Other examples of solids which sublime on heating include ammonium chloride, solid carbon 4 oxide, iron 3 chloride, and aluminium chloride.
Temporary changes have the following characteristics: easily reversible, no new substance is formed, mass of the substance does not change, not accompanied by great heat changes.
Some of the methods used to separate mixtures include decantation, filtration, and evaporation. Let us find out how these methods states of matter. In this topic,
some substances cannot be split into simpler substances by any chemical means. When iron reacts with sulfur, iron 2 sulfide solid is formed. Sulfur and iron are elements. An element